welcome to our podcast for our review and our quiz over Chapter 4. We are going to begin in the box labeled solid, liquid, and gas rotations. So if you find that first, begin with the first question. What is viscosity? And that is a liquid's resistance to flowing. And this is a great picture. It can be found online. As you move left to right, you can see here with the first picture, it moves, has very low viscosity, moves very well, very similar to water. Then things thicken up as you move to the right. So you can see it pours out in the first three. This one's probably a little more like kind of syrup. And then we have our final two, which have quite a bit of resistance to flowing. Which state of matter changes volume easiest? So which one changes the amount of space that it takes up? And of course, that's going to be gas. How are the particles in a solid arranged? And we've got a picture here. They're going to be packed very closely together. And remember, they do move. They do vibrate back and forth in place. So those particles are going to vibrate back and forth, and you can see the solid here. How are the particles arranged in a liquid? And again, we've got a picture. They're packed closely, but they do move around freely. So you can see there is some movement here. They are packed close, but they can move around, physically move around in space. So that's different than a solid that vibrates in place. This one, they do move around. And then our final one here for gas, and these are going to spread apart, filling all available space. So added some arrows here showing that that movement that they really make, which is even more, covers more space than even what the liquid does, which is good, or we wouldn't be able to walk around through the gas. Okay, moving on to my glass is leaking. What is sublimation? This occurs when the surface particles of a solid, so we're getting a solid, gain enough energy that they form a gas. So you can see here in the picture an example of this, going from a solid to a gas. That's sublimation. Condensation. Took a look at this during this investigation. It's a change in state from a gas to a liquid. So you can see pretty much when we ran that investigation, all you needed to do was just get that glass cold, get that cup cold, fill it full of ice, get that ice water. So put in the water, a little stir, get that going. And a lot of you, as we were carrying it to the steam chamber, or even in my class carrying it to the freezer, there was condensation already on that cup. Really doesn't take too much. Just drop that temperature. Vaporization. See the picture down here? That's a change in state from a liquid to a gas. Boiling. It's vaporization that takes place both below and at the surface of a liquid. So you can see that boiling, making your macaroni for your macaroni and cheese. What is melting? Change in state from a solid to a liquid. And freezing is going to be from a liquid to a solid. One of the best ways to remember these might just be to draw a picture and draw a picture of them either happening or draw a picture of them going from one to the other. And if you take a look back at your notebook for My Glass is Leaking, we have that diagram that we put in there during our Making Meaning conference that goes through each of these and has the arrows going kind of in that triangle from solid to gas and liquid to gas and so on. Gas laws. What does Charles's law state? That the temperature of a gas at constant pressure is increased. Its volume increases also. So the temperature of a gas at constant pressure, so you're not increasing the pressure. The temperature increases, the pressure stays the same, the volume is going to increase. So as you look at the picture here, you can see an increase in the temperature from the left side, which is negative 65 degrees Celsius, to the right side, which is 250. that increase in temperature, didn't increase the pressure, increased the temperature, and you can see that those molecules have more room here on the right-hand side. They have more room over here. And we increase the temperature. The pressure that's done here stayed the same. Boyle's law, when the pressure of a gas increases at a constant temperature. So now we're going to increase the pressure. So we're going to increase the mass here. So instead of this, we move to here. So instead of P equals 1, we go P equals 2. So now pressure increases, temperature stays the same, not changing the temperature. The volume decreases. So even if we were pushing on this, push down more, it's going to push down more pressure here. So it's going to be less room for these molecules. So Charles's law deals with increase in temperature. Boyle's law is an increase in pressure. How does heat affect pressure? Heat increases the speed of the gas particles. So as we increase the speed here, increase the heat, the speed is also increased of the gas particles, and so the pressure is increased. So they gain more space. What happens to the volume of gas when pressure is increased? Pressure increases, volume decreases. So it's the same thing here with Boyle's. Practice questions are listed here on this page. Have quite a few of them. Highly suggest you go through when you get a chance. One of your nights, just spend a time going through practice questions. Maybe you're 3 nights out, 2 nights out, doing some practice. This is something simple. Go through, bring that into Mr. Cora or myself, and we'll check those over if you want us to. Okay, watch this again. Take the practice quiz. Study with your parents. Don't just study by yourself. If you continue to study the way you've been studying and you're doing really well, keep it up. If you're continuing to study the way you've been studying and you're not improving, you got to change. You can't keep doing the same thing. Best of luck.